webinar today, SQL Server 2016 New Features. I'm your presenter today. My name is Stephen Giles. I'm the Director of Data Platform Maturity at Dimensional Strategies. My focus here really is on the core of the data platform. Now, we are primarily a SQL Server shop, but we do big data as well. And so my interest is really in controlling access to data in the data platform and all aspects. And my goals today really are to walk you through some of the new features of SQL Server 2016 and really talk about what Microsoft is doing with SQL Server. I've got a couple quick demos and some good information. If you have questions, please type them into the chat window. And I've left a few minutes at the end for questions, and we'll go through them. Just to give you a sense of SQL 2016's place in the ecosystem, this is the current Gartner Magic Quadrant for data platform. And what's really interesting here, this is the first time that Microsoft has been by itself up in the top left-hand corner. They passed Oracle this year. They've left everyone else behind. And this is really, if you read the analyst report, due primarily to the huge amount of features that have been added and functionality that comes right out of the box, whether it's for business intelligence or for data performance or for security. There's just a huge range of new features. We're going to go through them today. What's also interesting about SQL Server is not just that it is top of the heap as far as operational databases goes, it's also in the leaders quadrant, both for data warehousing and for business intelligence and analytics. And if you notice of all three magic quadrants, Microsoft is the only one that's in all three. There are different players and different niche players in each, but clearly SQL Server has a very special place in the data platform. Then SQL Server 2016, we have the full in-memory OLTP, which we're going to talk about. We have the stretching to the cloud, integration with big data, a whole bunch of new features, some really detailed security features, and it's all in one. So the Microsoft marketing term that you're seeing used all the time now is called everything built in, and it really is that. It's one price, one SKU, and then just a massive range of features. So let's dive into some of those features. I want to set the feature conversation today in the context of how I view the mature data platform. Now, this is my take on it, not Microsoft's, but it's how I really approach the data platform and plug all of the pieces in. So to my mind, a mature data platform stands on three pillars. You have security, and to me, security is not just access control, but it's monitoring and auditing, it's high availability and disaster recovery. All of these things fall under security for me. We have performance. If SQL Server doesn't meet the performance needs of your users, you're going to have complaints. We want to make sure that all databases are performant in whatever function we're carrying out. And functionality. Does it do what I need it to do when I need it to do it? And does it give me a complete package, or am I constantly looking to other tools to do things? So we want to look at a platform and judge it across these three pillars. So security, as I said, is really three pieces: auditing, access control, data protection, and high availability. So auditing is really just, can I see what is being done? Access control is what most people think of security. Can I control who gets into what, when, and where? Data protection is things like encryption or data masking, which we'll talk about. And high availability is my SQL Server always up when I need it? So let's dive into some of the new features specifically around the security pillar. A few things here. There are some very interesting new features that have come into 2016 around security. The first one on this list is actually not a SQL feature, but this is something Microsoft is rolling out across all of their products, and that is the advanced threat analytics. Essentially what Microsoft is doing here is they're taking machine learning and applying it to security. So for example, if I have a user log in North America and Asia on the same day within a couple hours of each other, we can probably flag that as an incorrect activity. Or if a service account starts poking around file shares, that's unusual behavior, and that is something that advanced threat analytics will detect. Auditing has been around for a while. Auditing has been tweaked a little bit in 2016. It's not a new feature, but I find it's a feature that very few people turn on. And auditing, I can be as coarse or granular as I want, right down to who is querying what records in a particular table. Authentication is something we're all familiar with, but there's two new features that really are interesting. One is row-level security, and the other is dynamic data masking. We're going to talk about both of those in detail. And then there's always encrypted, which is a new feature, which is really interesting for the conversations around the cloud, because it allows me to manage encryption at the client side and not at the data side. And transparent data encryption we've had since 2008, but it has been enhanced in 2016. So let's look at two specific features. I may have tables that have sensitive information where I need people to be able to see the tables but not necessarily see the information. So I may have CSRs that are looking up customer records, and I want them to see things like the name and the address, but I don't necessarily need them to see credit card number or phone number or some such things. So dynamic data masking allows me to determine what data gets displayed back to the user depending on who the user is. We can enable this on specific tables and specific columns. And when we run a query against those columns, the result sets we get back will be very different depending on who I am. So this is my SQL 2016 server. I have our familiar AdventureWorks database running here. But I have a specific table in here called customer PII, and I've set some masks on that table so that we can see it and work. Let's get rid of the properties box here so we got some more real estate. The first thing I'm going to do here, if I go and just select star from small table, just for those switching to 2016 on Windows 10, F5 will no longer execute queries. So I'll hit execute. And you can see here, the SIN and credit card number are actually encrypted on the database. So even though I'm an admin, that data is hidden from me, and presumably only the credit card purchasing people will have access to that data. However, there is email address and telephone number. Both of these are identified as personal information. And because I currently am logged on as an admin, I can see both email address and telephone number clearly. However, there are masks on both of those fields. So if I go and run the same query, but this time I run it as Michael 9, we see here the email address and the phone number have changed. So the phone number has been replaced by 4 X's, and the email address is giving me the first initial of the email address, the @ 4 X's, and then the extension for the email address. So that's all I can see. And that's because the mask that's applied here is applied to Michael 9. Now, suppose Michael actually needed, and all salespeople needed to be able to see that data. I can grant them this unmask permission, which is a new permission. And so if I grant this role the unmask rights and run the query again, now it's open again. And it's open because I've exposed it to the specific role. If I take Michael out of this role, or if I revoke the rights from the role, then we'll see when I go back in, it's not there. How we actually set this up, I'm going to just drop the mask off email address, and then I'm going to reapply it. So now it's gone. If anyone were to query the table right now, they would see email address. But I can go and alter this table again and say add masked with function equals and then email. Now, email is a built-in function. You remember that the mask was show the first initial, X out everything on either side of the @ and then show the domain extension. That's the default behavior of the email function. So if I go and put this back on, it'll just enable that back to the table. Now, I have other options. So in this case here, I'm going to change the mask using the partial function. The partial function will actually let me set my own string. So in this case, we're going to show 2 characters, and then Zs and ABAB, and then 4 characters at the end. And for the email, we're going to replace everything with 1s. So I execute this quickly. And then if I go back and requery as Michael 9 again, I can see those new masks have been applied. So we have 2 characters of the email address, then Zs, then ABAB, and then the file extension at the end. And my phone number is a mask of all 1s except for the last 2 digits. So this way, my CSR could ask, like, do you have a phone number, or what are the last 2 digits of your phone number? The customer could confirm that information to them, but the CSR wouldn't have access to the full phone number. So that's data masking. So Always Encrypted is a new feature that's quite interesting, and what it allows me to do is it allows me to configure my database so that the data is encrypted from the point in time that it leaves the client. And the way this works, we put a library on the client side, and unfortunately to use this, we have to modify our applications. The app makes a call. The call has an identifiable number here, in this case, social insurance number. The data, as it gets passed to the database, though, gets encrypted by the Always Encrypted library and actually gets sent encrypted across the wire and stored encrypted on the server. So the server never actually sees the unencrypted value. It only receives it as an encrypted ciphertext. Now, the same ciphertext will be created for the same value, so I can actually query against this server side using a where clause, and SQL Server will simply match the ciphertext together. So if I put in the SYN, SQL will actually just look up the ciphertext. When it retrieves the records and brings them back, the Always Encrypted client decrypts it as the value comes in, so the clear text comes back to the end user. So my user sees social insurance number, it sends social insurance number, but the SQL Server never sees the actual value of the social insurance number, they just see the hash. And that is really, when we're doing things like moving data to the cloud, it goes a long way to mitigate concerns around security. We also have some real increases in high availability and disaster recovery through Always On. A few new features that have been added in 2016. For one, we can now have multiple synchronous replicas, whereas before we could only have one. We can have a high number of asynchronous replicas, and those replicas do not need to be close. So I can actually have a few synchronous replicas in my local data center with my server, but then have my secondaries in a remote site or in Azure or wherever I want to put them. The other thing they've added as well is the ability to create load balance sets across readable secondaries. So I could have my primary operational database, I could push that out to multiple synchronous replicas, load balance them, and I can run my reporting against the replicas, and that'll give me near real-time reporting, because now I don't have to wait for log shipping or syncing or pushing things from a production system to a warehouse system to a mart to a report. I'm actually querying off secondaries that are continuously updated by Always On. So it's a really powerful new feature. They've also sped up failover both to the cloud and to my synchronous copies. So let's talk about the performance pillar now. There's a couple new features here I want to talk about. In-memory OLTP is a big one. Stretch database, which I'll actually show you quickly, and then we'll talk about query store. If we think of pre-2016 days, there was always a challenge with real-time reporting. So I may have transactions that are flowing into an operational system. I push them into a warehouse, and then I run my reports. Well, that sync between operational data store and warehouse could be 2 hours, could be every day. So if there are fraudulent transactions, for example, it could take me anywhere from 2 hours to 24 hours to even identify that they're there. Now, for just general reporting, that lag was never a problem. But when I want to do these kinds of real-time analytics, this is a problem. So the change here is that Microsoft has incorporated both the column store index and the OLTP and memory index together to allow me to essentially build covering tables all in RAM. And then I can run my real-time analytics against the in-memory index without impacting the performance on the server. So I can have lots of transactions flying into my transactional system. All of them are going straight into memory. And then I can run my algorithms detecting fraud against that column store index in real time. Now, this is not going to completely replace the data warehouse. I'm not going to change schemas or go from, fully normalized to star. But for things where I need to do heavy processing against active transactional data, this is seeing a huge performance increase. Microsoft has seen up to 30% times faster and reduction of queries from minutes to seconds. Stretch database is also interesting as well. For situations where I have very big tables that are for the most part cold, I can actually stretch them into a lower cost storage, in this case, Azure. So I can choose the table I want to stretch. I stretch it into the cloud, and SQL Server will actually keep the hot records close, send the cold records into Azure. And from an end user perspective, there's absolutely no change. My apps will simply call the SQL Server the way they always have. SQL Server internally will figure out where the record I'm looking for is and will retrieve the appropriate records. So no changes to the apps. I can also enable encryption on this so that my data in Azure is encrypted, but I can really get off my expensive local storage, all of these big, deep tables that are really not accessed frequently, but it's stuff that I want to retain. So let's actually take a quick look at this. So I have here in my sales schema, I have the order tracking table. This table gets very long. It also, as things age, it becomes colder and colder. So if I go into AdventureWorks, go into, and stretch table is enabled here. I simply connect up to Azure, and I specify the tables I want to stretch, and I set up sync. I won't walk you through the full process because it takes too long, but let's just do person here. Stretch, enable. I then choose the table that I want to stretch, and there's something in here that's preventing it, so that's okay. Point it to the SQL Server, and it does everything else for me. I get a monitor that I can see what is being stretched. So if I go into the database itself and go to monitor, I can see what I'm stretching, I can see the health of it, I can see whether or not things are in sync. And if I go into SQL Server, so this order tracking, right now, out of the 180,000 eligible rows, 0 rows are local, all of them are in Azure. That's because nothing has been hit, so there is no hot data. Run a query against the data itself. It pulls back the subset of data. I didn't have to specify where the data was. All of this data came out of Azure. If we go into the space use now and go back into the report, we'll see that some of this data has been pulled local again. So that's StretchDB. Very simple, a great way to get things into offline storage. The Microsoft Query Store is a very useful feature. With Query Store, what we can do is we actually can see the application of execution plans over time. So I can watch queries over a period of time. I can see performance of those queries. So this is great if I want to find, for example, periodic slowdowns where I think 2 processes are in conflict, but I don't know what they are. I can go in here and I can see the conflicts over time. I can also see the plans that were executed on each one. And if I find that there are certain plans that work better than others, I can force SQL Server to use the plan I want to use. Now, this is really useful if I'm migrating from earlier versions of SQL Server and I have execution plans that work better in the old platform than on the new platform. I can capture the old execution plans from my older server, and I can apply those execution plans on the local server. This is something we could never do in SQL Server before. The optimizer made its choice based on the statistics that it had in hand. And I could execute a query, but I couldn't tell SQL Server how to execute it other than with the odd processing hints. This actually lets me take a series of execution plans and say, SQL Server, no, when you execute this query, this is the plan that you're going to use. It finally puts some stuff back in the hands of the DBA that was never there before and really allows for the execution plan choice to be made by the DBA and not by SQL Server. So the last pillar is functionality. There's a number of new things here. Many of them are BI related. There is support for big data, which we'll talk about, built-in advanced analytics, and then the integration to cloud, which I find really interesting from an infrastructure perspective. Integration with big data comes through the addition of a feature called Polybase into SQL Server 2016. Now, Polybase isn't new. It was available in the Microsoft APS, which is their large appliance, massive multiprocessing data warehouse application. And they've basically moved it into regular SQL Server. And what it allows me to do is, as a DBA, I can define objects in a Hadoop data store. So I can use Hive or Pig to define tables, which are then populated from Hadoop. That data gets pulled into SQL Server into memory through Polybase. and then I can query those objects with Transact SQL. So I can build virtual data sets in SQL Server that are actually being derived from a Hadoop system as their source, and issue T-SQL statements against them and get result sets back. Not only can I query these tables that I create, I can join them to my existing table. So in this example here, I have customer information in my SQL Server, but I have telemetry data from their driving in my Hadoop data lake, and I'm able to pull the telemetry data, pair it up with the customer data, and get more intelligent information around giving quotes for customers. So I can quote on you based on your driving record. So there is support for HDFS here. There is also support for JSON as a data source with Polybase. The advanced analytics space is one that's really interesting. In this advanced analytics tool, we really see the integration of tools like R into SQL Server as a first-class citizen. So whereas traditional Transact SQL was good for set-based analysis, was good for general reporting, to do the real statistical data science work, SQL Server just wasn't suited to do it. So to do things like fraud detection, building propensity scores, so given what I know about a customer, what products are they most interested in, all of these kinds of activities require a tool like R to do that kind of analysis. So SQL Server has added a number of new features. The first one, which is really key, is that I can now call R right from within Transact SQL. So I can write a query then in standard SQL, but I can then make R function calls from within that query. So if I wanted to pull information about a customer and then a propensity score for that customer, my single query could pull the customer data using Transact SQL from the SQL Server, but it could also use R to drive the propensity information. You couple that with the column store index that we talked about earlier in the in-memory analytics, and that's where I get my real-time data. And I think of all the features that pulls BI and the functional additions of SQL Server 2016 together, that is really one that is key, because now I can do things in near real time, and fraud detection is a perfect example. If there are hinky transactions going on, I don't want to find out about that a day later. I want to find out about it while the transactions are in flight so that I can flag them or cancel them or do whatever it is that I need to do. Having that R functionality built into SQL Server makes that possible. SQL Server has also fully integrated a very large multi-thread MPP server product for doing detailed data science work, and that is the R server. If you remember a few years ago, Microsoft bought a company called Revolution R. This is the implementation of Revolution R. It is incorporated fully within SQL Server. It's included with the licensing for SQL Enterprise. And so all of these R features are available to me right out of the box with SQL Server. So there's some great new features there. The other thing that's really interesting with 2016, and if you've been following Microsoft and their drive to the cloud, none of this should be surprising, but they have added full integration between on-premise SQL Server and a number of features in Azure. And so this goes back to the hybrid cloud story, and it's not really marketing fluff. It's actually a very well-baked solution that allows me to maintain my data on-premise that I want on-premise or that I need to have on-premise for compliance or whatever other reasons. But I can leverage the economics and the elasticity of the cloud to extend functionality of the SQL Server and also to drive costs down. Backup is a perfect example of this. SQL Backup has been around as long as SQL Server has been around, but I always had two choices in backup. I could back up to a storage location, usually a file share, or in earlier days, I could back up directly to tape if I had tape drives locally attached to my SQL Server. The backup to tape feature's gone away. Tape has pretty much gone away as well. And instead, we can back up directly from my on-premise SQL Server into Azure Storage. Azure Storage is a very low-cost storage option. I can also back them up into a geo-redundant storage account so I can push my backup files into blob storage in one data center. I can have it located to another data center, and in the event of a true disaster, I can actually restore that backup up in Azure to another SQL server in Azure and get myself back up and running. So that gives me low-cost storage. It also gives me full geo-redundancy without me having to build multiple data centers in multiple cities. And it gives me recovery capability because once that backup is up in the cloud, I can then have a SQL server already installed in Azure that's turned off and cold and not costing me anything. I can stand it up. I can restore my backups that are already in Azure to that SQL server, and I can bring it online. And then, with a little help from the magic of DNS, I can get my files routed over to it. I can use Active Directory throughout. I can have single sign-on. I can give my SQL Server service accounts the ability to write things into the Azure Data Store. There's a lot of capability there, and it doesn't force me to take my data off-site. That I can really keep my data local, but not use expensive local storage as the place where all my backups go. This way, I'll get triple redundancy in the local data center, and if I choose its geo relocation option, I also get triple redundancy in the cloud. Disaster recovery also becomes key because not only can I have backups sitting there waiting to be restored, but I also can create secondary replicas in Azure. In fact, I could run my backups from the readable secondary in Azure. So not only could I store my backups in BlobStore, but I can actually make the backups in Azure, which means I don't have to push my large backups across the wire to get them up in Azure. And I can do this with Always On. I can set up my primary server on-premise. I can create a VPN connection between my on-premise network and Azure. And I can stand up active asynchronous secondaries in the cloud and have Always On failover from on-premise to the cloud if I need to. And because it's across the VPN, I don't have to worry about my applications. My applications are talking to a listener name, and that listener may be served by the primary on-premise server, or it may be served up by the secondary that's in the cloud. I can also do things like use the cloud version as a report server. I can run different Power BI off of it, for example, through the gateway. There's lots of different permutations I can create here, but all of them allow me to extend myself outside of my data center, and for disaster recovery, that's critical. I can put things outside the 100-mile range if I need to, which, for Azure data centers, I can pick any data center in the world. And I can then have the cloud act as a backup location, so I can actually fail over from on-premise to the cloud. The extension is probably the least well-defined, but one of the most interesting pieces of it. Hybrid cloud really gives me scale. So once I have that VPN created, I can do things like burst from on-premise to the cloud if I'm getting heavy load. If I want to have multiple copies of something that are synchronizing on the back end, so I've got European operations and Asian operations and North American operations, I can have the servers out where the customers are. So I could put one piece of a farm in the European data centers, one in the Southeast Asian data centers, one in Australia, one in South America, one locally. And because everything is VPN connected and because everything is Active Directory authenticated, I can treat that as if I had multiple physical data centers that I was working with. When we talk about cloud scale, I think that's the most important piece. Yes, you can have hundreds of petabytes of storage. You probably will never need hundreds of petabytes of storage, but it's the ability to scale up when I need the resources and scale down when I don't. And a lot of these features, that we looked at, that scale becomes important because sometimes, especially with things like reporting, if it's year end or quarter end, there may be some really heavy requirements around reporting, and then the rest of the year there's not. so I can scale up my footprint into the cloud during those peak periods and then shut everything back down as I no longer need it. And that cloud bursting and that dynamic elastic scale of the cloud really is what gives it the functionality and the advantage. And that's really, when you think about cloud, it's not about how big could it be, it's do I have needs that change over time? I'd like to thank everyone for joining today. I hope you found it useful. If you do have questions, please reach out to me anytime. Thank you.